And thank you all for coming this morning. Every year, this show gets to be bigger and more relevant in the industry. It's great to see the progress. So today, I'd like to focus my time here on what's happening at the intelligent edge. And it's another area of fast innovation. So I'd like to start with a little bit of a story and an example. We recently had our company's developers conference in Scottsdale, Arizona. And as I sat down to watch the keynote, for that, I sat next to a gentleman, and as we're getting started, I asked him what he does. And he says that he develops security systems for boats. And I said, oh, that's nice. And I said, well, why are you here? He says, well, because we want to add a lot of new functions to a boat security system. You know, the owners may not be there, and you might have ring cameras and things like that at home, and want to have that similar thing for a boat. But the interesting thing is he wants to be able to do that and to be able to look and evaluate the images that are there, but there really isn't a big pipe like at home where you have Wi-Fi or a hard line to be able to get to the cloud and evaluate those images. So he needs to be able to develop a system that can evaluate those images in real time right on the boat, and then if there is a threat, then that's when you would turn on the cellular link to be able to draw an alert and to be able to do more. But to do that, you need a lot of compute and a lot of intelligence at the edge, and it also needs to be power efficient, right? So there's many different types of applications that you see here across that demand this new level of computing at the edge. You see there on the left-hand side at the top, medical imaging. That's one of our customers that has an ultrasound, and this is battery powered, and it needs to be very power efficient. But again, being able to process those rich images. You look at the aerospace and defense or space. Again, this is something that is out disconnected from networks, although maybe a small bandwidth, but nothing high bandwidth in real time. Embedded vision, you see there in the industrial applications. Images need to be evaluated exceptionally quickly. You don't have the latency to be able to go across the network and hit a data center to be able to do these things. Decisions need to be made locally. Similarly, at the industrial edge, on the edge of a 5G network, in a car, we've heard more examples of the level of processing that needs to be done in that zone of the car, and decisions need to be made quickly. And so that you need that level of compute. So the requirements of this is it's not easy, right? It needs to be scalable. It could be battery powered. And it could require a lot more performance at the edge. And then there's also, you'll find a lot of areas that we see where they're thermally or power constrained. And because it's going into a tough environment, no airflow, and so they all need to be quite efficient. But all these nodes that are at the edge of the network, they expose a large attack surface. And so security is also of the utmost importance. And to be able to do that and provide, very, very secure products. So they need to be flexible as well to deliver this. It's that mixture of real-time responsiveness, latency, and sometimes running on bare metal. But on the other side, running large communication stacks, human-machine interfaces, and then more and more every day is the need to be able to put more AI and ML processing there at the edge. So with those functions of a mixture of real-time, Linux, and then safety security, we need to have multiple and flexible ways to be able to process that. So, in our products, what we're putting in here is you'll see the flexibility that in this example here, symmetric multiprocessing with a monitor core to be able to provide that oversight to make sure that all run well. But that can be scaled to asymmetric multiprocessing applications, where a couple of the cores could be running in RTOS, some could be running Linux and running the human-machine interface, doing networking applications. Or they could also be, you could take a couple cores and you can set them up for lockstep operation to give the fault tolerance that's needed for mission-critical applications. And then in the hard real-time case, again, you could dedicate all these cores to be able to be running real-time operating systems. So this is really important, and I also like to point out the over-the-air updates are also critical. Recently, the EU just passed on the Cyber Resilience Act. So not only do these products need to be secure at the day they ship, but they also need to be able to be maintained for a long period of time to ensure that they're safe over time. And so those over-the-air updates are becoming even more and more important. So as you saw in that first boat example, there's all these things that are now being envisioned to be able to go to the edge, but they want to tap into AI processing and ML processing. And we see that, of course, in that boat example, that was imaging processing, but it could be in industrial applications, it could be doing predictive maintenance on the machine, on a motor, a compressor. The robots themselves, they need to evaluate many different things in real time exceptionally fast. Could be evaluating images and making a decision of what to do. And then, great examples in the previous presentation about, the level of autonomy that needs to be inside of a vehicle. And that's also up in, in space, as well as, the number of satellites keep going up and up and up, and with our low Earth constellations, and being able to do that processing there, in situ is exceptionally important. So to be able to handle that, we are, engineering our products to be able to handle those AI and ML processing workloads. And that's one of the best things about RISC-64, is it is customizable, it's extensible, and it allows us to be able to tap into that, to be able to put into our products customizable vector processors that make it fantastic. We get orders of magnitude of processing capability or power savings for doing these new types of workloads that are being pushed to the edge. Now, we've been coming here for quite some period of time. Starting in 2016, that's when we started working on RISC-V processors. We were doing that on the basis of soft cores that were going into our FPGAs. We followed that up in our PolarFire FPGAs with an entire SoC microprocessor subsystem in addition to the FPGA fabric. And really working throughout the industry to be able to provide the entire suite of software, operating systems, IP that's required to bring these types of products to market. More recently, we based our new high-performance space flight computer that we're developing in conjunction with NASA and JPL on RISC-V. And our PolarFire 2, which is getting close to its final stages of development, is also based upon 64-bit RISC-V processors. Most recently, though, we also announced a new family of PIC64 microprocessors. And we have several new versions, and these are targeted more towards the edge computing platforms. And so we announced in July, we announced PIC64GX, which is a I call it a pentacore because it's a quad core complex, plus it's got the 5th core to provide that supervisory function, which is a real unique thing because you need that combination of being able to do the, a quad core Linux application, but be able to have, real-time capability supervising what's going on there. And then the PIC64HX. So yesterday, this is a new one that we announced yesterday. So this is an octal core processing running up to a gigahertz. It has, as I mentioned before, it has this customizable vector processing capability that's built in, and it's going to deliver more than 25,000 DMIPS of performance and optimized for AI and ML workloads. Now, one of the other interesting things that we're doing, as a company, we have the scalability that we provide from literally, we make 8-bit microcontrollers that have 6 pins that go into the smallest applications you can imagine. And now, and each year we ship on our microcontrollers and our microprocessors, we ship multi-billions of those products today. And what we're doing is kind of exciting, is that we're connecting that to have a continuum that customers, our hundreds of thousands of customers that we have today that are using these microcontrollers, microprocessors that we deliver today, we're allowing them to be able to migrate up into the PIC64 realm and tap into the power of RISC-V. So we all know it takes a village. I think I'm preaching to the choir on this one. Yeah, it's way more than a piece of silicon. As one of the other speakers mentioned before, I completely agree. I think the software is becoming more important than the silicon itself. And so that's why we need to work together on the operating systems, the tools, the middleware, to be able to develop complete solutions that customers can tap into. And so that's where, many of you, I think, in the audience here are represented on this slide, and, we'll continue to work together to deliver these products. Now, one of the things, as we are, and as I said, we do billions of products a year. We like to be able to make things as easy as possible to get started. And so with PIC64, there's no exception. So we've just brought out a new, what we call a curiosity board. It's a great place to get started for people. So it's got this, the pentacore that I call it. So it's got the quad core plus the monitor core. Supports that mixed criticality that I talked about in the earlier when you saw those architectures. It's got a gig of memory on there, connectivity, and it's available now. We're shipping them into the warehouse and for a attractive price of $150. So we really want to get the market going. We're solidly behind it, and we think this is a great tool. So you can stop by our booth. We'll have one of these in the booth that you can see it, and talk to our experts there that can tell you more about it. So with that, that concludes my remarks. I want to say thank you to the audience here. Thank you to Calista and the rest of the event organizers for putting on another great show. Thanks. Have a good day.